everyone. So today we are going to discuss some thermodynamic past paper questions. Okay. So first of all, let's discuss question number 2000. There was a statement question. Okay. So they have given a diagram. This is pressure axis. This is volume. Okay. So this is the diagram. So there are three processes. Okay. A, B, this is 1, this is 2, this is 3. Okay. So what the question they are telling is this. An ideal gas is taken from state A to state B separately along the three paths shown in the PV diagram. Okay, if UV is greater than UA. If UV is greater than UA, consider the following statements. Okay. So the work done by the gas is same for all three processes. What they are telling in the A statement is the work done by the gas is same for all three processes. So how do you find the work done? So we know if there is a pressure versus volume graph. Okay, let's say this is the graph. So area under this graph, it gives the work done. Because what is work? Work is equivalent to P into delta V, change in volume. Okay, so area under the PV graph gives the work done. Okay, now you see, this is one process. This is second process. This is third process. In all three cases, is the work same? No. If I consider the first process, work done by the gas is given by this total area. For the second process, if we consider this area only. Third process, this area only. So they are telling the first statement, the work done by the gas is same for all three processes. No. For the work done by the gas is high for which process? W1. So first statement you can write it again. W1 is greater than W2. That is greater than W3. Okay. So there is two things. One is work done by the gas. Other one is work done on the gas. Those words also you must maintain. Now when you consider, here see, let's say the volume is V1, volume is V2. The volume is increasing. Then the gas is doing work. So that statement is correct. Work is done by the gas. In the first process, second process, third process, all are going from the initial position A to final position B. So in all three processes, work is done by the gas. But the work is not equal. It is high in which one? In the first one. So the first statement we can write it as W1 is greater than W2, that is greater than W3. Okay. Then B statement. Then first statement is wrong. The corrected one is this. B statement what they are telling? Heat is absorbed when the gas is taken along path 1. Whereas heat is liberated when taken along path 3. Okay. So in thermodynamics, we have only one equation. What is that equation? Delta Q is equal to delta U plus delta W. Isn't it? Yes. So you must know what are these terms. This is the heat energy. Okay. This is the internal energy, increase or decrease. This is work done by the gas and work done on the gas. Which is plus sign, which is minus sign, you must know. This is heat absorbed or heat liberated. Okay. So they are telling heat is absorbed and one case heat is liberated. So let's say that means one case there should be a plus sign, other case there should be a minus sign. Isn't it? One case they are telling heat is absorbed, other one is heat is liberated. So I'm going to tell the sign things. If you can't remember, see here. Delta Q is equal to delta U plus delta W. Okay. If work is done by the gas, delta W is plus. When is delta W is plus? Work is done by the gas. Okay? The gas does work, delta W is plus. If we do work is done on the gas, it is minus. Work is done on the gas. Okay? It is minus. So when is delta U is plus? Delta U will be plus for internal energy increase. Internal energy increase. If internal energy increases, delta U is plus, other way delta U is minus. Okay? So when can be delta Q plus 6? If heat is absorbed, Okay, delta Q is plus when heat is absorbed. Other way around, when heat is liberated, delta Q takes minus sign. Okay, so you have to know in which case what sign it will take. In theory, we study what is the reason why we are considering this is plus and minus thing. This is a short way. Now we are doing equations thing. Okay. So B part what they are telling is heat is absorbed when the gas is taken along part 1, whereas heat is liberated when taken along part 2. Okay. Consider 1 and 3. If you consider process 1 as well as process 3, you see work is done by the gas. Okay? See from A to B, volume is increasing. So delta W is plus for both cases. Process 1 also it is plus. Process 3 also it is plus. Why work is done by the gas. So what about delta U? Internal energy increase. That means delta U means U final minus U initial. Okay. So see, if you consider part 1 as well as part 3, both the parts final is B. This is initial. So they have given one. UB is greater than UA. When delta U is also plus for both the situation. So for both the situation, delta Q should be plus. But what they are telling, heat is absorbed. One case it is plus 2, other case it is minus 2. Therefore, definitely that statement is also wrong. So how can we correct that statement? Heat is absorbed when the gas is taken along part 1. Along part 1 also heat is absorbed. Along part 3 also heat is absorbed. Then the temperature of the gas at state B is higher than the statement C. Okay. So you know there is a relationship between this internal energy and temperature. Delta U, internal energy, is directly proportional to temperature. Okay, that we derive in the theory. Okay, you can remember for ideal gas molecule. Okay, first of all, we talk about normal energies, kinetic energy, potential energy. Since there's no attraction, no potential energy. So mainly it has kinetic energy. Then we say what there are two types of kinetic energies. One is translational kinetic energy, other one is rotational. Then you know the reason. There is rotational kinetic energy is due to that moment of inertia property. No, you have studied in theory. Therefore, we say that internal energy of an ideal gas mainly it is determined by what? Translational kinetic energy. Can you remember? Internal energy is directly proportional to kinetic energy. We say. Then we say what? Kinetic energy is directly proportional to absolute temperature in the theory. And finally we come to a conclusion for an ideal gas molecule. Now, for ideal gas, okay, internal energy is directly proportional to our temperature. Okay? Okay, then if you consider C statement, the temperature of the gas at state B is higher than the state A. Temperature is high. Yes, definitely. Why? UB is greater than UA. Therefore, internal energy is high, means directly proportional. Therefore, TB is directly proportional to T. So, no need to give this data also. You can easily find. Why? We know the equation. Can you remember? PV is equal to nRT equation. So R is constant for fixed amount of gas. N is also constant. So PV is directly proportional to temperature. Temperature is directly proportional to internal energy. Then where PV is high, at that place internal energy is high. You see pressure. Let's say there is a pressure P1 here. Let's say there is a pressure P2 here. Then what is here? P1 V1 is what? That is the U1. Then P2 V2. Definitely P2 V2 is high. So therefore, what we can say, UB is greater than UA, we can come to this conclusion directly looking at the diagram. No need to give that given to make the question easy. Therefore, for this question, what is the answer? We can go to C. Only C statement is correct. Therefore, we can go to the third answer. Okay. So there is another statement question in 2001. Okay. So now today we are going to see how to do these statement questions in thermodynamics. So if you consider 2001 question, this is pressure, this is volume. Okay, so they have given you a diagram here. So they have told this is volume is V1, pressure is P1. Then volume is V2, and pressure is P2. And they are making some statements. They have given UB greater than UA. This is A and this is B. Okay. An ideal gas is taken through a cyclic process as shown in the PV diagram. If UB is greater than UA, consider the following statements. Okay. The net work done by the gas is positive for the whole process. Okay. So what is happening is, now the first process, the gas is taken through this pathway, A to B. Then it is coming from B to A. So they are asking the net work done by the gas is positive for the whole process. Okay. So we know delta Q is equivalent to delta U plus delta W equals. Now, for a cyclic process, what is the shortcut? For a cyclic process, delta U is equal to 0. Why for a cyclic process, delta U is equal to 0? Now, initially it is starting at A. Then it is going from A to B. Then it is coming from B to A. So, initial position is also A. Final position is also A. Internal energy change means what? U final minus U initial, isn't it? U final minus U initial. That means P1 V1 minus P1 V1. Then delta U is 0. So from today you must remember for any cyclic process, okay? So the any cyclic process, it can be a cyclic process or any process. For any cyclic process, delta U is equivalent to 0 for the whole process. Okay, so this is equivalent to 0. So what they are telling is net work done by the gas is positive for the whole process. Yes. Why? Now you see how can we find the net work done? Net work done for A to B. When you consider A to B process, the work done is given by this shaded area. That A to B is what? Work done by the gas. See, A to B volume is increased. Then work done by the gas. Then B to A, what happens? B to A volume is decreasing. Okay, that is work done on the gas. Then the net work done is given inside this shape. Okay, so net work, which one is high? A to B is only higher, no? That is what? Work done is by the gas. Therefore, that is correct. The net work done by the gas is positive for the whole process. Therefore, statement A is correct. Statement B. Heat is absorbed along the path A to B, whereas heat is liberated along the path B to A. They are telling. Okay. So A to B pathway. Okay. You consider A to B pathway. Okay. For delta U is 0 for the whole process. Now the whole process means A to B, then B to B. Now I am going to consider A to B process. Okay. So when I consider A to B process, what I can tell? See, A to B process, work is done by the gas. Therefore, delta W is plus. Okay. Delta U is also plus. Right? A to B. UB is greater than UA. Delta U is what? UB minus UA. Therefore, delta U is plus. So, delta Q should be plus from A to B. That means what? Heat is absorbed. Okay? Heat is absorbed on the path A to B. That is correct. Next one they are telling heat is liberated along the path B to A. So, when we consider the path B to A, for B to A path, we can write delta Q is equal to delta U plus delta W. So when you consider that pathway, what you can tell? So volume is decreasing. Volume is decreasing means work is done on the gas. Then delta W is minus. Delta U is also minus. See, for B to A process, delta U is UA minus UB. Isn't it? UA minus UB. Therefore, that is what? That is also minus. Then definitely delta Q is minus. Delta Q is minus means what? It is liberated. Therefore, B statement is also correct. So, when you consider C statement, the temperature of the gas at the beginning of the process is same as the end of the process. Yes. It is beginning at A and ending at A. See? Then, in both these places, UA and A. Initially also internal energy is UA. Again, it is coming for this position, it's UA. So, if the internal energy didn't change, temperature also will not change. Why? Internal energy is directly proportional to temperature. So, if the internal energy is not changing, means Temperature also will not change. Therefore, here A, B, C, all three statements are correct. Therefore, we can go to the fifth answer. Okay. So there is another statement question. Okay. So it was 1999 question. So what is the question is they are given a diagram. This is pressure and this is volume. Okay. So this is the given diagram. Okay. This is IAF process. This is IBF process. So what is the question they are telling is this. Again, there are three statements A, B, and C. An ideal gas can be taken from an initial state I to A, final state F by the process. So one process is IAF process, and the process IAF process, and the process IBF process as shown on the PV diagram. Consider the following statement. Maximum work is done by the system during the process IAF. Okay? Okay. See, during the process IAF, the work done is given by this shaded area. Isn't it? Yes. Now, if you consider it individually, IAF process, this is the work done by the gas. A to F process, no work done. See, no area bounded with the x-axis. Or else you can see here, when you consider A to F, volume didn't change. Work is what? P into delta V. So if the change in volume is 0, so work is 0. So therefore, IAF is this area. Similarly, if you consider IF process, the work done is given by this area. IBF process is work done is given by this area. So in which the process, the work is maximum. Maximum work is done by the system during the process. IAF only we are doing maximum work. Therefore, that statement is correct. The change in internal energy of the system is the same for all three processes. Yes. See, if I consider IAF process, initial position is I, final position is A. If I consider IF process also, initial position is I, final position is A. If I consider IBF process also, initial position is I, final process is A. So everything it is given by UF minus U1. That is the change in internal energy. So that is what they are telling. Change in internal energy of the system is the same for all three processes. That statement is correct. The maximum heat absorption occurs in the process IBA. That we can easily say, you see, delta Q is equal to delta U plus delta W. Second statement only now we told delta U is what? Say all three processes, internal energy changes same. IAF also, IF, IBA. In all three processes, change in internal energy is same. So which one, the heat absorption is maximum? In which process heat absorption is maximum is in which process work is maximum. So in which process work is maximum? That one first one is telling IAF process. Therefore, if they tell IBF process, that is wrong. Because internal energy changes same for all three processes. IAF process, IF process, IBF process. Because see, this F minus I then. Therefore, which one work done by the gas is maximum? That one only what? Heat absorbed is maximum. Therefore, only A and B are correct. Okay, C statement is wrong. Okay, thanks for watching.